Before we begin with partial fractions with quadratic denominators, let's first of all go through how to solve this linear partial fraction. Even though this fraction has a quadratic root, it has two roots, one of them is a quadratic root. We cannot term this as a partial fraction with quadratic denominators. Why? Because with this particular factor, if we are to break this factor down, we are going to get two linear factors. So this makes this entire question a linear partial fraction. Now, first of all, let's try to break this quadratic factor down. For difference of two squares, when we break this factor down, we are going to get x minus 1 and then x plus 1. So this is equivalent to, we have three linear factors. So that is why we have a, b, and then c. So let's find our LCM. X minus 1 cancels x minus 1. We'll be left with x plus 1 and then x plus 2, which will multiply the numerator. So we have a multiplying x plus 1 and x plus 2 plus. Now, if x plus 1 cancels x plus 1, we'll be left with these two factors, which will multiply the numerator b. So we have x minus 1 and x plus 2 plus. Now, if x plus 2 cancels x plus 2, we'll be left with these two factors. So c multiplying x minus 1, then x plus 1. Now, since the denominators are the same, let's deal with the numerators. Let's use the cover-up methods to make it very simple. Now, if we are to put x to be 1 here, it will make the entire c to be equal to 0. It might even make b to be equal to 0. So let's put x to be equal to 1. So this will give us let's simplify further. If x is minus 1, it will make a to be 0, so that we'll find the other one. So when x is equal to minus 1, is 1. Now, if we put x to be equal to minus 2, we'll make a to be 0 and then b to be 0, so that we'll find c. So when x is equal to minus 2, give us minus 413. So this will be the fraction from
identities involving quadratic denominators.
Now, I will use the two methods to solve this identity, so that when we start the partial fractions with quadratic denominators, you can choose the one you most prefer. So let's start with the comparing of coefficients. If you get an identity of this form and you have to compare coefficients, what you do is that you want to compare what is at the left-hand side with what is at the right-hand side. So what is at the right-hand side should be in the form of what is at the left-hand side. Let's expand the brackets. So by expanding the brackets, we'll end up getting, so ax squared, a times 4 is 4ax, a times 5 is 5a, plus we have two brackets multiplying, and under algebra, we know how to multiply two brackets. So x times bx is bx squared, plus x times c is cx, plus 2 times bs is 2bx, plus 2 times c is 2c. We are to group like terms. Let's not forget the equivalent to this side. After grouping them, let's factor the common term out. Now, this is where we compare coefficients. We know what a coefficient is, any number written in front of a variable. Now, this is the x squared term, and this is the variable. Now the coefficient is what is written in front of the x squared variable. Now let's see. The left-hand side, there is no x squared term. So that let's assume that aspect is 0x squared. That is why it is not written. So if that is the case, let's compare the x squared terms. What is in front of them? We have a plus b is now equal to 0. So we have our first equation. Now let's compare the x term. We have 4a plus 2b plus c is equal to, the x term here at the left hand side, the coefficient is 2, so it's equal to 2. This is our equation 2. Now the constant terms, 5a plus 2c is equal to, now the constant term at the left hand side is 3. And this is equation 3. So let's make a the subject of equation 1. So b is equal to minus a, and a crosses the equal to sign. Let's turn this as equation 4. Let's put equation 4 into equation 2. This will be equal to 4a plus 2 times b. We now know that b is equal to minus a. So minus a plus c is equal to 2. Let's simplify. Let's term this as equation 5. Now let's make c the subject of equation 5. So c will be equal to 2 minus 2a. We have an equation for c. Let's put c into equation 3. So equation 3 is 5a plus 2c is equal to 3. But c is equal to 2 minus 2a. So let's put c into this. We're going to get 5. We now have the value for a. We can go and put a into equation 1 in order to get the value for b. Well, equation 1 is a plus b is equal to 0. Now a is equal to minus 1. So let's put it in. We have minus 1 plus b is equal to 0. Now b is equal to positive 1. We can now put both a and b into equation 2 to find c. There's equation 2. So let's put them in. Still on the same question, let's now use the cover-up method to solve. One trick is that for you to make b to be equal to 0, always if you are to put x to be 0, it will make b to be 0. So let's start with that one first. Now when x is equal to 0, this will be let's put x to be minus 2 to make this side to be 0. Now when x is equal to minus 2. A to be minus 1. Now trying to make this to be equal to 0 will be difficult. So let's just make x to be 1 here so that we'll get a value for a. So when x is equal to 1, what happens to a? Equation 1, we're going to get so putting a and c into equation 2, we're and these are the same answers as we use the comparing of coefficients.
Example 2.